Alright, problem number 2, a bunch of different series here. We want to write using sigma notation and then find the sum. So, to do so, let's look at A. Let's first recognize if this is geometric or arithmetic, or maybe B, it's something totally different. So, how do we get from 14 to 8, and how do we then, in that same way, get from 8 to 2? Well, let's just try and see if this is arithmetic first. If I take 8 and I subtract 14 from it, what do you get? Well, you get 6, and it's a negative 6 since we're going down. 8 minus 14 is negative 6. So is our pattern just subtracting 6 each time? Well, 14 minus 6 is 8. 8 minus 6 is 2. 2 minus 6 is negative 4, and so it does, in fact, work. And so we can write an explicit formula here. We can say a sub n equals our first term, 14, plus our common difference, which is a minus 6, times our expression n minus 1. And we can use this to figure out what term number negative 76 is. So negative 76 equals 14 minus 6 times n minus 1. And we can solve for n. So let's take negative 76 and let's subtract 14 from both sides. We've now moved this over there, which means we're left with that negative 6 in front of my n minus 1, so I need to divide by negative 6. So now we divided that down, which means we're just left with this bit, n minus 1, so I can add 1 to both sides to get n. You can do that in separate steps, but I'd do it all at once. And on your calculator, that will tell us that n is 16. And so we know that this is the 16th term right there. We want to write this series in sigma notation and find its sum. So to write it in sigma notation, we need to say we're starting with the first term up to the 16th term. We need to put our explicit formula to the right of it, which means I need to write my 14 minus 6 multiplying the expression n minus 1. And this will equal the summation, which is n over 2, the number of terms divided by 2, so 16 over 2, times my first term plus my last term, which is negative 76. And we can calculate that sum, which is negative 496. And you could do it using a summation on your calculator as well. Both should get you the same exact thing. So that is part A. Now let's do part B. Do it in purple this time. Again, the idea is let's figure out, first off, is it geometric? Is it arithmetic? Well, it certainly is not arithmetic because we are dealing with a bunch of varying fractions there. And so we need to think of this in terms of a geometric series here. Well, how do you get from 1 to 1/3? Well, we are dividing by 3. But the question is, does that work for the next one? If we take 1/3 and divide by 3 again, we don't get 6, which means that this sequence isn't geometric, which means we need to look for a pattern. And anytime I'm looking for a pattern, I always start by writing the term number underneath and seeing if I can identify a pattern between the term number and the actual term itself. Well, one thing you can do is you can notice that we definitely have a pattern in those denominators. 3, 6, 9, 12. We're increasing by 3 each time. This next one would be 1/15. But how do we write that? Well, one way you could handle this is to think of that as an arithmetic sequence just in the denominator. What would that first term be? Well, if this is our first denominator there, that first denominator has to be 1. Because the only thing you can divide 1 by and get 1 is 1. And so that actually doesn't fit our pattern, right? Because according to our pattern, if we're increasing by 3 each time, we would need that to be a denominator of 0. And that doesn't make sense because we can't have a denominator of 0. So what I'm going to do is I'm kind of going to ignore that 1 for now, and I'm going to adjust everything. And so instead of thinking of that first term, let's think about everything else, and let's just move this forward. Let's forget that 1 for now. We'll add it in later, but let's start our sequence with 1/3. Because if I start my sequence with 1/3, then I can see that in each instance that denominator is just 3 times my value of n. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. And so that pattern fits there. And so what I'm going to do is I'm going to say, let this be the sigma from n equals 1 up into infinity. Totally lying there. I don't know why I said infinity. This is not infinite. We have a defined stopping point right there. But it is 1 over 3 times whatever my value of n is. But now let's kind of remember that we have that awkward plus 1 there. So let's just do 1 plus this sigma. And so 1 plus that sigma there, but we need to know how far do we go. And so for that, we need to use this term. If 1 over 39 is in the form of 1 over 3n, let's figure out what n is. So let's solve for n. So we could cross multiply, and we could say 3n equals 39, which means that n equals 13. And so this sigma can go up to the 13th term, and now I can add all of this together on my calculator and call it a day. So use the sigma notation on your calculator, or do the sum of a sequence of 1 over 3x, comma, x is the variable, comma, start with 1, comma, end at 13. Get that number, and then don't forget to add 1 to it. And you should get your number, which is, and I just noticed I typed this incorrectly, that denominator 3x needs to be in parentheses there, so be careful with that. But when you crunch that number, you should get 2.06. Now let me show you real quick on your calculator. You would get there, let's go down here. On your calculator, you would hit second. Where is it? You would hit second, and then you would hit the stat button, and then you need to choose the math option right there, and then it's option number 5. It says sum. And then after you do that, you need to go second again and stat again and choose the ops option. And again, it's the 5th, but this time it is sequence. We are summing the sequence, and then you would type it in like I have in purple there. Or if you have the new operating system, all you have to do is hit alpha window and then choose the summation option, which then you can just type it in and you can actually make it look like that right there. Then add 1 to it, call it a day. Either way, you get 2.06. All right, now what about part C right here? What is the pattern? Again, I am going to list my n's underneath it. Hopefully that will help me. So n equals 2, n equals 3, n equals 4, n equals 5. And now I need to look for some patterns here. Well, one pattern I can identify is that each exponent is 1 less than my term number. Even on that first one, if there were an x here with a power of 0, that would be the same as 1. So I know that I'm going to have something raised to the power of n minus 1. That will give me an exponent of 1 less than the 0. I'm sorry, 1 less than the term number. But then what goes inside the parentheses? Well, one thing we could do is we could look at the term that has an exponent of 1, because if that has an exponent of 1, then that's probably what goes inside. But the trick here is that it is not just the x, it's that whole 2x. And that will, in fact, work. Because think about what happened if you plugged in n equals 1. Well, the exponent would be 0, and that would make the 2x to the power of 0 go to 1, our first term. And if n was 2, we'd get an exponent of 1, giving us just 2x. And if n was 3, we'd get 2x squared, which 2x quantity squared is 4x squared. And then if n was 4, we'd get an exponent of 3. And 2 cubed is 8, and x cubed is x cubed. And same on for n equals 5. 5 minus 1 is 4. 2 to the 4th is 16, and x to the 4th is x to the 4th. So, sigma notation starting at our first term, and we're going on forever because the dot, dot, dot. So let's do this last one real quick. This one appears to be geometric as well, and that means if we want to figure out what the ratio is, we need to take a term like negative 20 and divide the previous term, which is 40. Negative 20 over 40 does cancel. 2 over 4, I have a ratio of negative 1/2, which means if I'm writing this as a geometric sequence, n will start at 1 and go to infinity, and I will have my first term, which is 40, times my common ratio, which is negative 1/2, raised to the power of n minus 1. And I can calculate this sum because it will be the infinite sum of a geometric sequence when r is between negative 1 and positive 1. So we can use our infinite summation formula, s of infinity equals first term divided by 1 minus my common ratio. And so I can take my first term, 40, divided by 1 minus my ratio, which is negative 1/2, and now I can simplify things. So 40 divided by 1 minus negative 1/2 is 1 plus 1/2, so 3 halves right there. And 40 divided by 3 halves is the same as 40 times 2/3, so I get 80 over 3 as that sum. So those middle two problems there, not super easy by any means, but first one and that fourth one there should absolutely be doable for you.